Let's look at an example of the Wilcoxon sign rank test. This is used for parametric data. Otherwise, we don't assume in normal distribution it could be shaped like whatever. And this is commonly used for paired data. So here's an example of paired data where we're looking at the weight of different people before a diet as well as after a diet. So first step of this rank sum test is to calculate the difference. So our difference here is -9 plus 8, 0 plus 7 minus 8. Oh, that's minus 12 actually. Whoops, minus 12, minus 10, minus 14, and then minus 2. And then we're going to rank the absolute value of the difference. So absolute value of the differences. So 0 is the smallest one, then 2, 7, 8, 9. There you go. And then let's now put the sign of the difference. So we'll have that negative here, negative here, negative here, and a negative here. So let's calculate our Wilcoxon statistics. So we're going to have our Wilcoxon positive statistics. And for our positive, it's going to be the 4 plus 1 plus 3 plus 2. And that gets you 10. And then let's get our negative numbers. So our negative numbers are 5, we'll put negative 5, 7, 6, 8, and that gets us negative 26. And then to compare to the critical value, you want to take the smaller magnitude of the W, so let's say absolute value, which equals the 10 here. It's the smaller the value. And then 10 happens to be bigger than our critical value. In our case, we have 8 people. The critical value for 8 degrees of freedom is 4. And what does this imply? This implies we fail, interestingly, to reject the null hypothesis. And the null hypothesis is the median difference is 0. So the median difference is, close to 0 in our case. And it makes sense because half the users kind of have a positive value and half the users have a negative value. And then the level of the extremity isn't extreme enough for us to reject this hypothesis.